Okay, now that we've laid some foundations for the theory of the Atwood's pulley, let's actually look at a question, or a typical question, and I'll show you kind of the work that would be expected, say, for a written response. So we have two objects, mass 1 and mass 2. They're connected by a light rope over a light frictionless pulley. So M1's got a mass of 25 kilos, M2 has a mass of 30 kilos. So we want to determine the magnitude of the acceleration for each block when they are released. So on this pulley, mass 2 is going to have a force of gravity pulling it down, and we're told that this has a mass of 30 kilograms. Counterbalancing that, this first mass, the mass of 25 kilograms, that is going to act against this second mass. Now, the direction of the acceleration, this mass, since it's heavier, this is going to accelerate down while simultaneously M1 is going to go up. And that acceleration is going to be dictated by the difference in masses here. So for this, let's have a look at the acceleration. So we know by Newton's second law, we know the acceleration is the net force divided by mass. So for this, we know that the mass is just the total mass of the system. So we got this M1 plus M2. That's the total. Now the net force is always that tricky one. The net force is going to be driven by that difference in mass. So that difference in mass between the two pulleys, that is what's going to drive our system. We have our pieces together now, or I should actually make these uppercase M since they are that in the question. So I know my net force is going to be that difference in mass, which is going to drive this system. I know the mass is the total mass, so the acceleration of this system, it's going to be this difference in mass times the acceleration due to gravity. And then we're going to divide that by the total mass of the system. Every single Atwood's question that you do is going to have the exact same formula 100% of the time. These will not change. So the last thing we're going to do, let's actually calculate it. So we're told the second mass is 30 kilograms. We're going to subtract that off with 25. Then we're going to multiply that by 9.81 meters per second squared. And then we're going to divide this by the total mass of the system. So we got 25 kilograms plus 30 kilograms. So that difference in mass times g divided by the total mass, we're going to get about 0.89 meters per second squared. Now it just asks for magnitude. I don't need direction or anything. So the acceleration of this system is about 0.89 meters per second squared. What this is trying to tell us is that both of these blocks accelerate at 0.89 meters per second squared. So this first block here, it's going to go up at 0.89 meters per second squared. This second block here, it's going to move down at 0.89 meters per second squared. They're both going to accelerate at the same rate. The only difference between them is they're going to go in different directions. One's going to go down, one's going to go up.